Welcome back once again. My name is Mr. Charles Fonike. In today's video tutorial, we'll be discussing on different types of diode or types of diode. In my previous video, we discussed on diode, what diode is all about, and I also added a little function of diode, which I also said that diode can be used as a rectifier, which can be used to convert a current from AC to DC. But in today's video, we'll be discussing on types of diodes, and one topic, as in one of the types of diodes, will also be added. I am going to explain it more on this particular video, but in that, the one that we are going to discuss after these types of diodes in this video now is called Gunn diodes, and that is the video, and that is when the exact diode that we are going to discuss. How comes about the Gunn diode? Who invents Gunn diode? How does it function, and how does it work during when current has enter it and when current is also leaving? How does it function, and does it have positive and negative semiconductor, or it only has negative alone? So in that case, we'll be starting from types of diode before going to Gunn diode. So there are several types of diodes are available for use in electronics design. Just as I said, we cannot do anything in electronics without diode. And I also explained in my previous video that diodes is either active or passive component, all depending on the specific function that you are using the diode for. Because I am not going to tell you that I will classify diode as active or classify diode as passive, all depending on the specific function that you want to make use of the diodes. So in that case, there are types of diodes are available for use in electronics design, namely the backward diode, the Barrett diodes, and Gunn diode, and also laser diodes, light emitting diodes, photodiodes, PIN diode, PN junction diodes, Schottky diodes, step recovering diode, tuner diode, ferrator diode, and a Zener diode. So there are other previous diodes which I may not be able to put it here. If you have discovered or observed that there is diode that I have not mentioned, which as you are watching through this video, you can as well comment on below. But in that case, these are the diodes for the moment which I have seen so far, and that is the reason why I also make this video here as well. So you can see the various types of diodes, different types of diodes, how it look like. All these diodes, we are going to discuss each of them in details, one after the other, or one by one. So in that case, the one that we are going to discuss today, just as I said, is Gunn diode. So these are the different types of diodes which I just mentioned, though it might not be only these. There are other ones as well, which I may not be able to put it here. We also have transient something diode. That one is work as surge protector. It protects the circuit. We will discuss that one as well, but I did not add it here. So in that case, this one is Gunn diode. We have LED diode. We have PIN diode. We also have recovery diode. We have Zener diodes, Schottky diodes, Barrett diodes, photodiodes, laser diodes, and tuner diodes. All these diodes will be discussed in details. Now, this is the exact one that we are going to discuss, since this one is the part of the diode that we all have. So we will be discussing this specifically. I will explain this in more details. So in that case, Gunn diode, it's also known as, this is called AKA, it means also known as transfer electron device. It is also known as transfer electron device. Is a tip is a type of diode having negative resistance like tuner diodes. Once we'll be discussing of tuner diode, you will see how it works and how it functions, or how it works or how it functions as well. So in that case, what here is saying that another name of Gunn diode is transfer electron device, and that is another name because of what it having a negative resistance like tuner diode. So it is named after a British physicist, J.B. Gunn, who discovered the Gunn diode in 1962. A man called B.J. Gunn who discovered this diode, and it was named after the name of the man, and it was in 1962, and that was when this diode has been when it started being in existence of diode family. So remember, the man that discovered it is a British man, and is also a physicist, and it is called J.B. Gunn. You can use this Gunn to remember that that is the name of the person that invented the diode. So in that case, the diode, the Gunn diode, does not have a p-n junction. You know, majority of diodes, it has p-n junction. P-n junction, it simply means positive and negative. The P stands for positive, the N stands for negative. But in this case, this Gunn diode, it does not have any positive and junction. It contains only negative junctions. So we are going to look at the images and see how it works as well. In fact, it consists of only n-type material. This is n-type material, which is why it does not rectify AC. That is the reason why it does not rectify AC. It only works as a normal diode. It does not rectify AC or work like a normal diode. It does not rectify AC, or it does not also work like a normal diode, because it only contains the N material type, the N semiconductor material. So in that case, it is also the reason many people call it transfer electron device. That is the reason why majority of people, they call it transfer electron device diode, and that is the another name of it. It is called AKA transfer electron device instead of diode. In case if you have heard about transfer electron device, it is also called diode because it has all the three terminal. It was negative, 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 and that was the reason why it only transferred. Now, the image of the Gunn diode. Look at the symbol, and look at the positive and negative. And look at the positive, as in the N material, it carries positive also. Now, what I'm explaining here is this. All the material that the Gunn diode is using, they are all N-type material, and N-type material is a negative type material. So in that negative type material, now during the manufacturing or the process of manufacturing, they have to make it, that N-type material, they have to make it, instead of P-type material at the one side, N-type of the material at the one side. Then at the middle, it 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 now it has the positive and the negative as well at the middle, so that it can so that it will have the ability to jump from the negative to positive, and from the positive to negative. But in this case now, it only has n types of material, and that n type of material, what happened was that from the it took the position of that n type and that p type, and also the position of n type. So instead of it to be given positive and negative, it was all labeled positive legs. As in, the two terminals are called positive leg, but that does not mean that it has p type material. So this is the symbol, this is the finishing product image of Gunn diode, how it look like. Now, it consists of three n-types layers. Just as I said, it consists of three n-type layers, two of them which on the terminal side have a higher resistance. That positive sign that you're seeing there, it simply means that it has the higher resistance than the one at the middle. The positive sign simply means that it has a higher resistance. So now, doping concentration, whereas the middle thin layer has lighter doping concentration. In terms of doping, the middle has lighter doping concentration, while the other aspect of it has higher resistance to it. Now, this one is when voltage is applied to Gunn diode. Initially its current increases with increase in voltage. When voltage is applied in that n-type material, being the Gunn diode, initially what happened was that the current increases with increase in voltage. That is initially. Now in this case, at higher voltage, the current resistance of the middle layer starts increasing with voltage, and that is the reason why it is called transfer electron device, because of the way it works and because of that material that it used. The two sides of it, they have high resistance, while the middle, in terms of doping, it has lighter aspect of it. So in that process, whichever way the current is coming from or the voltage is coming from, initially the voltage will do what? Increase. Now then at the point, that particular tiny side, which is the lighter, will also increase in voltage, both in voltage and as well as in current. So in that case, it results in the fall of current flow. It results in the fall of current flows, and this is the negative resistance, and that is why it's a negative resistance. It doesn't have any positive resistance in that of it. It only has negative resistance, and Gunn diodes operate in this region, and that is how it operates. It does not operate with positive, it only operates with negative resistance, and that is why it is called Gunn diode, because the Gunn diode is a man that invented it. Why another name of it is called transfer electron device. That is another name, and that is the reason why majority of people call it that particular name, because of how the material is being used and how it works during when current is applied or when voltage is applied to it. So that is the use of this Gunn diode is used in generating microwave high frequency. The use of Gunn diode, the Gunn diode is used in oscillator for generating microwaves of high frequency. And I believe that some of you that are watching this video as well will understand how to construct oscillator and what oscillator is all about. So in that case, during this oscillator, it is also used in microwave of high frequency, and that is those are the only function for this for now which I know about the Gunn diode. I think I would like to end this video here for the moment. Maybe next week we proceed from where we stop. Please, if you like my video, subscribe to my channel, comment, like, and share. Thank you once again. See you next week.